Hey everyone, and welcome. Today we're going to dive into something huge, the evolution of AI. We're not just talking about AI that can spit back facts, we're talking about AI that is actually learning to reason. We're going to break down, step by step, exactly how machines are learning to think. So you got to wonder, what's the central question here? It's this: how do we get an AI to understand the world not just as a string of text, but as this giant, messy, interconnected puzzle of sights, sounds, and ideas? How does it actually learn to connect the dots and draw conclusions in a way that feels, well, truly intelligent?
The key idea we need to wrap our heads around is something called multimodal reasoning. And you could just forget about AI that only knows how to read. We are talking about an AI that can look at a picture, listen to a sound, read a caption, and then think about how all those pieces fit together. It's like we're finally giving AI senses, and now we're teaching it how to think with them.
So how do we know all this stuff? Well, everything we're talking about today comes from a massive research survey. And when I say massive, I mean it. They analyzed over 700 scientific papers. So this isn't just one lab's opinion. This is basically a map of the entire field's progress.
Okay, so here's the game plan. First, we'll set the stage for what AI reasoning even is. Then, we're going to walk through 3 distinct stages of its development, from the absolute basics to some seriously deep thinking. And then, we'll peek into the future at a whole new kind of AI they're calling native thinkers.
All right, let's get into it. Part 1, AI that reasons. Before we jump into the different stages, let's just make sure we're on the same page about what it means for an AI to truly think. The researchers came up with this really brilliant 4-stage framework that kind of mirrors how humans develop. Stage 1, that's like infancy. It's all about basic perception. Stage 2 is like childhood, when language starts to give structure to your thoughts. Stage 3, that's adulthood, where you get more complex, deliberate thinking. And stage 4, well, that's a future we're just starting to wrap our heads around. So let's start at the beginning, with the AI's infancy.
Okay, here we go. Stage 1, the building blocks. This is the absolute infancy of AI reasoning. So back in this early phase, AI systems were kind of cobbled together with these separate specialized parts. Think about it like this. You show the AI a picture of a dog. One little module identifies the object as a dog. Another one reads a caption that says golden retriever, and a third one tries to glue those two ideas together. The thing is, the reasoning was just a side effect of these different tools working. There wasn't a central brain understanding the whole picture. It was like having a toolbox with a hammer and a wrench, but no one who actually knows how to build a house.
And that brings us right to stage 2, thinking out loud. You can think of this as the AI's childhood, the moment it discovers that language is this incredible tool for organizing its thoughts. The big breakthrough here was a technique called multimodal chain of thought. Now, instead of just guessing the answer, the AI is prompted to literally think out loud first. It generates a step-by-step rationale that connects all the dots before it gives you the final conclusion. And this is a huge deal, because it starts to crack open that AI black box and show us its work. Let me show you what I mean with a super simple example. So imagine we show an AI a quick video clip and just ask, what's happening here? An older, stage 1 AI? It might just make a wild guess. But as stage 2 AI, it uses this chain of thought. So first, it just says what it sees. Step 1. I see a cat and a ball of yarn in the frame. Yeah, it's stating the obvious, but that's the point. It's the crucial first step to ground its thinking in reality.
Then it starts to notice the relationship between things. Step 2, the yarn is unraveled and spread around the cat. See? It's not just listing items anymore, it's looking at their condition, their context. And because it linked those two simple observations, it can draw a totally logical conclusion. Final answer: the cat has been playing with the ball of yarn. It's a simple example, but it perfectly shows the power of making the thinking process visible and deliberate.
But, just thinking out loud has its limits. It's great for simple cause and effect stuff. But to solve really complex problems, you need stage 3, deeper deliberation. This is the adulthood of AI, where it goes beyond just reacting and starts to do long-term strategic planning.
The researchers make this fantastic comparison to the idea of System 1 and System 2 thinking in humans. Stage 2 is like our System 1 brain. It's fast, it's intuitive, it's our gut reaction. But Stage 3 is all about developing System 2, that slower, more deliberate, analytical part of our brain that can chew on really tough new problems. This is the leap that lets an AI plan a whole research project, not just describe a picture. The key takeaway is the shift from just reacting to actually planning. And this is not just some theory for the future. It is happening right now, and it's happening incredibly fast. Just look at this timeline. The appearance of models that are specifically designed for this deeper System 2 style of thinking, you see them called the O1 or R1 families, it's all happened in the span of just a few months. We are literally watching the whole design philosophy shift in real time.
So we've gone from infancy to adulthood. What could possibly be next?
Well, that brings us to the final, most mind-bending part of the roadmap.
Stage 4,
the future of AI with these so-called native thinkers.
Honestly, the vision for these future models is just wild. Imagine an AI that doesn't see text and images as separate things, but understands everything, sound, video, even weird sensor data, in one single, unified way. That means it can be proactive. Instead of just answering your questions, it can anticipate what you need, create its own plans to solve a problem, and then change its strategy on the fly based on new data. Kind of like a scientist realizing their experiment isn't working and redesigning it right there in the lab.
This quote from the paper just nails it. Reasoning is no longer retrofitted onto language models, but instead natively emerges from omnimodal perception and interaction. What that really means is that the ability to reason won't be some feature they bolt on at the end. It'll be a core, fundamental part of the AI's DNA.
And that leaves us with one last, pretty fascinating question to think about. When an AI can see and hear and read and truly reason about the world as a built-in, native skill, what on earth will that unlock for science, for creativity, for all of us? It's a future that's getting here a whole lot faster than we think.